Now let's start the second part of today's lecture. Just before the break, we learned how to interpret an identifier. When you have an identifier, how are you supposed to know the value of that? Because we are interpreting an expression under an environment, we are going to look up the environment. Look up the environment with the name and ask the environment, hey, do you have a value for this name? And if the environment has the value, it's going to return that to you. Otherwise, it's going to throw a free identifier error. Then, how do we know the value of this identifier? How does it get into this environment? What do you think? How do you know the value of y? Because before evaluating this name, we had something like this. Val y equals some expression. The value of this expression is going to be the value of this y, and then maybe some more expressions, and then y. That's how we know the value of y. That's how we know that the environment has the value of y. And what is this one? This case. Now let's see how we can evaluate this expression. One more time. That's going to be val x equals I semicolon b close. How do we evaluate this expression? We first evaluate this first sub-expression, get the value, and x's value is going to be the value of I. Using that information, we are going to evaluate body b, right? Again, we are going to evaluate I first under the given environment. When we evaluate this first sub-expression, we are going to use this environment. Then this function call is going to return an integer. Whose value is that? It's going to be the value of x. What are we going to do with that information? Using that information, we are going to evaluate body b, meaning that we are going to interpret the second sub-expression b under which environment? That is the question. What do you think? You should think, not me, right? When we interpret the function body, what's going to be the environment? What is an environment anyway? It's a mapping, right? It's a map from names to values. Why do you need that? Because while evaluating this body expression b, we may encounter some expressions like addition, subtraction, another value, identifier introduction, things like that. But while evaluating this b expression, you may encounter some names. Then you need to look up the values of that names in this environment. So we should have all those information already in EMV. And what else? And one extra point is x's value. So we are going to extend this environment EMV with this new piece of information saying that, hey, you know what? X's value is the value of the first sub-expression. We are going to get the value of the first expression by interpreting it under the given environment. So we are going to add this new mapping to an existing environment. That's how we know all the information already given to us and the value of this new name x. Using this environment, again, what are we going to do again? We are going to interpret b. We are going to interpret the second sub-expression b under this extended environment. Is it clear? This is very important. This is the two lines that implement two new language constructs for VAE. right? Are you with me now? Then let's see what we have been implementing in the operation semantics. Growing the language. We are grow the language from AE to VAE. In AE, there were only 3 language constructs. I'm going to use the capitalized thingy. Num, add, and sub. There were only 3 case classes to construct an object of type AE. And now we are growing the language AE to VAE by adding 2 more things. What? Val and ID. So we grew this language called AE with VAE. So again, the concrete syntax is this. Abstract syntax in Scala is this. ID with a name, string name, ID introduction. We introduce this name whose value is going to be the value of this first sub expression, and the value of the whole expression is the value of the second expression. And how do we evaluate the second sub expression? By evaluating that under a new extended environment. How did you extend the environment? You should know. Okay. Then this is the semantics. We talked about concrete syntax, abstract syntax, and semantics in Scala implementation. One more time, a language has syntax and semantics. Syntax describes what it looks like. Especially there are 2 kinds of syntax, concrete syntax and abstract syntax. Concrete syntax is more like how you type the thingy in your keyboard. String representation. Abstract syntax meaning what that actually represents. There is a function that takes a concrete syntax and then produces abstract syntax. Concrete syntax in this string thingy, and then constructs an AST, abstract syntax tree. What's the name of the function? Parser. Parser takes some expression in concrete syntax, produces in abstract syntax. Until now, everything is about how it looks like. And what that means, what do you mean by that? That's semantics, right? In semantics, we discuss 2 ways of describing the semantics. First, interpreter. Second, operational semantics. Interpreter in whatever language you like. But in this course, we are going to implement the interpreter in Scala. This is yet another programming language that we love. We really like Scala. It has many good features that we can discuss later. And this is the semantics of VAE by writing the semantics as an interpreter in Scala. So you know what it is, right? Well, really, one more time. What's the value of ID, name X? How do you know its value? We are gonna look up the environment using the name. What's the value of this val expression? The value of the whole expression is the value of the second sub-expression. How do you know the value of second sub-expression? We interpret that expression under new environment. What's the new environment? This addition meaning that on top of this given environment, we add new mapping saying that the value of this name, newly introduced name, is the value of the first sub-expression. How do we know the value of the first sub-expression? By interpreting it under this environment, right? And now we are going to describe what we've been talking about in Scala in operational semantics. Do you see that? Yay! Operational semantics, pretty mathematics in Greek letters, expressions and environments. Now the expression E, it has 5 cases. Number n, or addition of 2 expressions, subtraction of 2 expressions, or introduction of a new name whose value is the value of this first sub-expression, and the value of the whole expression is the value of the second sub-expression. And finally, a name, right? So again, the number n is an element of the integer set. The name x is an element of the set of variable names. In Scala, we represent that as string, if you remember. In Scala, we represent that as int. An expression E is an element of the set except. Yeah, let's call that except. Except for expressions. Environment is a map, but it's a finite map from variable names to integers, meaning that it's a map from variable names to their values. It's finite in the sense that the domain of the map, meaning the set of variable names, is finite. There's only finite numbers of identifier names. And we are gonna use this Greek letter called sigma to represent an environment. In Scala, this map EMV was implemented as a new type named EMV, which is a map from strings to integer. And finally, value v is the set of integers. So far so good. Let's use this notation to write down the operational semantics. From now on, we are going to use blue color for the template of the operational semantics. It's a template. It's like operational semantics of this language called VAE, or language called E in the set named except, right? It's gonna in this form, saying that under this environment sigma the value of this expression is v. Okay, this is a template, meaning that whatever expression is, in order to know the value of this expression E, we need an environment. Under that environment, evaluating this expression results in a value V. Let's look at the first example of that, which is the simplest one, number. This one says, hey, interpreter, if the expression that you are going to evaluate is a number, then the value of this expression is going to be that number. How can you write that in operational semantics? Under whatever environment sigma that's given, when we evaluate n, its value is going to be the value n. Simple, right? So there's one-to-one correspondence. Interp of expression n under sigma, some environment sigma is what? N. These are just the same. Do you see it? How about addition? In Scala, we say that, hey, interp, the expression that you're evaluating is addition, then I know that you have two sub-expressions. Then we are going to interpret the first sub-expression under the same given environment, get the value. We are going to evaluate the second sub-expression under the same environment, get the value, and we are going to add them. How can you write that in operation semantics? Just the same. Under whatever environment is given, we are going to evaluate E1 plus E2. What's the value? Oh, in order to know the value of E1 plus E2, we need to evaluate E1 and E2. Yeah. And yeah, it's a recursive call. It's a recursive call. And you said the same environment. Oh, that's good. The same environment, sigma. Under the same environment, sigma. What's the value of E1? I don't know, but that should be a number. So let's call that N1. Under the same environment, sigma, we evaluate E2. What's the value of E2? I don't know, but that should be a number, so let's call that N2. Then, what's the value of this addition? That's N1 plus N2. We already saw this before, right? Yeah, you're not confused. We already saw this. And subtraction, that's just different operator, but the same thing. Yeah, please, let's move on. What's the new thing? The new thing is identifier, right? The new thing is identifier. How are we going to evaluate the identifier? Remember? Look at that. Hey, interp. The expression that you're evaluating right now is a name. How do you know the value of the name? You know what? With some magic, I don't know what happened, but actually I know. But yeah, the value of identifier should be in the environment. Otherwise, it's a free identifier error. Oh yeah, how can you say that in the operation semantics? What do you think? Yeah, I know you can see that blurred letters, but you'd better think first. What do you think? How can you say that? There are many ways to say the same thing. There are many ways to write down the same thing in operation semantics, but that's just one way. Under given environment, when we evaluate some identifier, what's the value? In order to know the value of an identifier, we need to see whether the given environment sigma has a mapping for the name X. Meaning that, hey, in the domain of the environment sigma, does X exist? Do you see that? One more time. For a given name, that we'd like to know the value of this name, then we need to look up the environment. Hey, you environment, do you have a mapping for this name? How do we ask that question in the operation semantics, in mathematics? Remember, sigma was an element of EMV. And EMV was a map from variables to their values, which was a finite mapping. So what we are asking here is, hey, sigma, what's your domain? What's your domain? Meaning the set of names that you have binding, you have mapping. In that domain, do you have X in there, right? Meaning that, do you have the value of X? So if it's this hypothesis, so if the hypothesis is satisfied, then we know that sigma has a mapping for X. Then we say the value of X is the value mapped in the environment sigma. Sigma X meaning that it's a mapping, right? Map from names to values. So we are going to check, hey, sigma, what's the value of x? Hey, sigma, what's the value of x? Then it's going to return integer back. Do you see it? So far so good? Then you may ask, how, what? But in the Scala implementation, what we did is that when x was not in the domain of environment, it threw an exception, free identifier error, but it does not say anything about it. That's a really good question. You should ask that question, okay? The operation semantics describe only valid cases, meaning that when you have some wrong code, incorrect expression, then among those operation semantics rules, nothing can be applied to your wrong expression. That's going to be an error. Okay, so if you have some name y and that's not in the domain of a given sigma, it's an error. It does not satisfy this hypothesis. You cannot apply this rule. That's an error. Okay. Finally, how do we describe the interpretation of a new name introduction? Let's see. Under some environment, when we are introducing new name whose value is the value of the first sub-expression, and the value of the whole thing is going to be the value of E2. What's that? In order to know the value of this relatively complex expression, we first need to evaluate E1. Okay, how do you evaluate E1? How do you evaluate E1? Under the same environment. Yeah, under the given same environment, evaluate E1. Let's call that V1. Okay, it's V1. And what do we do? And then we are going to evaluate the second sub-expression. We are going to evaluate the second sub-expression under which environment? Under this new environment. On top of the given environment, we add this new information. On top of the given environment, we add new piece of information. What's that new information? The name that we are introducing now, x, its value is V1. Oh, wait, what was V1 again? V1 was the value of the first sub-expression. Using that information, evaluate E2, and then we are going to get the value of V2. That's going to be the value of the whole thing. Do you see that? Yeah. Here, one of the most important things, really important concept is that we are using two different environments in evaluating E1 and E2. Let's see. When we evaluate, in this expression, there are two sub-expressions, E1 and E2. When we evaluate E1, when we evaluate E2, we use two different environments. How are they different? They share the same part here, and the second environment, this one, has one more information about x's value. Meaning that, do you see that? Meaning that when you evaluate E2, you can see x and you're going to have the value for x. But when you evaluate E1, you may see x, that's going to be an error. Do you see? Because sigma does not have any information about the value of x. X is not yet introduced when we evaluate E1. So when you see x here, that's going to be an error. That's really important. You should be able to understand that. Thanks for listening. And now you have exercise number 3 that's available from Piazza. We do not grade your exercise number 3. We do not check whether you do that or not, but it is your responsibility, and actually it's going to help you understand what we have been discussing in this lecture. So I strongly recommend you to do exercise number 3 earlier than later.